Right, so in this video, I'm going to talk about kind of why we learned how to simplify with long division and synthetic division. So division is very important in math. So it helps us simplify, it helps us to find factors. So if we wanted to know, is 3 a factor of, let's say, 18? The way we would figure that out is we would take 18, we would divide it by 3 and see if we get a whole number. So we get 6, we don't have a remainder, so the answer is yes. Now let's say I wanted to know, is 3 a factor of 17? Okay. So again, I would take 17 and we'd have to divide it by 3. So 3 goes into 17 5 times, so that would give us 15. We would subtract to get 2, so that would be our remainder. So since we got a remainder other than 0, the answer to this one would be no. Now again, why is that important? Well, if something's a factor, that means that we can multiply those two numbers. So 3 times 6 gives us 18. So if we think back to our previous unit on quadratics, we did a lot with factoring. So the dividing part, so long division, synthetic division, is going to help us find factors of polynomials. And this becomes important when we are dealing with cubic and quartic and quintic polynomial functions. Quadratics are easy because we've already talked about how to factor those. So even if we go back to one of our beginning problems, when we were looking at x squared plus 3x minus 40, well, instead of dividing by x minus 5, if I just factor that, okay, so the x squared would be split as x and x, and then two numbers that multiply to be negative 40, add to be 3, are positive 8 and negative 5. So when we factor, if I multiply these back together, that's the answer that I'm getting. So when we look at this problem, well, we divided by 5, and we got x plus 8. So that remainder here is 0. So that's another way that we can tell that x minus 5 is a factor of this quadratic equation, because I got that remainder of 0. Now again, with quadratic equations, that's easy to see because we know how to factor those and we know what patterns to look for. But if we go to a harder problem, so let's say problem 5, how do I know how to factor this? Or how do I know if this is even a factor of this problem? Well, we don't, but we can use division to help us. So if we go through our dividing process and we get a remainder of 0, then yes, that is a factor. If we get anything else, it's not a factor. Okay? So since we got a 5 here, this is not a factor of that. So I can't take my answer times that to get this polynomial function without using the remainder. Now on problem 6 and problem 7, when we were looking at those examples, when we divided, we got remainders of 0. So what we divided by and what we got for an answer, those are both factors of this polynomial. So that means that I can take 3x plus 1 times my answer of 3x squared minus 7x plus 2. Okay, well, yeah, that's nice, but why do I care? Well, remember, we learn how to do new techniques, and we always take those new things and we apply it to solving. So if I asked you to solve this cubic equation, well, we don't know how to factor it. None of our other formulas that we know work for that. So we need to start applying new techniques. So we're going to use division to figure out if we have a factor. And once we write it like this, if we set it equal to 0, well, I'm taking 3x plus 1 equal to 0, solving it. So we would subtract 1, divide by 3. So my first answer is negative 1/3. Well, my second term, it's a quadratic equation. So we would either try to continue factoring, or we could complete the square or use quadratic formula to solve that to get our remaining two answers. Okay? So the whole point of division is to take a higher polynomial, simplify it down to a linear term and a quadratic term, and then solve those problems. So same thing with synthetic division. Okay, so if we go through our synthetic division and we get a remainder of 0, so that means that I can take, for this problem, x plus 3 times x squared minus 3x plus 9. Well, I have two factors. I have a linear factor, so I know one answer has to be negative 3. And while this is a quadratic, I know it's not going to factor, but I can plug these numbers into the quadratic formula. So we would have 3 plus and minus the square root of 9 minus 4 times 1 times 9 all over 2 times 1. And we can simplify that, and that gives us our remaining two answers. Okay? So we're going to be using division to help us factor problems so that we can solve cubic and quartic and quintic, 6th degree, 7th degree, whatever degree we have, type polynomials. So that's the purpose of learning how to divide polynomials into each other. We're going to use it to help us factor, which in turn is going to help us solve. And one more important thing to know about division is that we can also use it to evaluate. So if we take a look at problem 8, let's say that I wanted to evaluate this problem for -1, which happens to be my 0. So that means that I'm going to substitute -1 into all the x's and then simplify. So here I would have 3, and then -1 cubed is still going to be -1, minus 4, and then -1 squared is a +1, plus 2 times -1 minus 1. So this will be -3 minus 4 minus 2 minus 1. Well, if I start combining those, so that will be -7, -9, -10, and notice that that is the remainder. So sometimes it's easier, it's a lot faster to go through this synthetic division process to evaluate than it is to plug these numbers in for the x's and simplify, especially if we're not using 1. So like if I wanted to evaluate for 10, I would much rather use synthetic division to evaluate it than have to figure out all the 10 to the powers times this number, combine like terms. So it's just a faster process for evaluating. So that would be the second importance of learning how to divide polynomials together. So again, we're going to use them to figure out if things are factors, and we can use it to evaluate polynomials. And that's going to conclude section 2.